Okay, so this tutorial, there's actually quite a lot of material, so we'll try to go a little bit fast, but it has two parts. The first part is me. It's about the core of Spark. We have an IPython notebook, so we will show a demo and with test data. So we will show some of the operations that you can use. There will be some slides as well to talk about the Spark execution model. And then there will be a break, and then Sahan comes in, and he will talk about data frames and SparkSQL. And so these are new features that came out, I think, last year. And then throughout the talk, there will be some mentions of configurations and just advice that we've learned at Skimlinks using Spark for a whole year. So for more than a year now, I think it's like 2 years. But anyway, yeah, so we know stuff. Great. So the data sets are from Amazon, and so we were asked to put the references. So it's a very small sample, and there are two of them. One of them is product reviews, and they basically have the ASIN, which is the product identifier. So we will talk about them quite a lot. They have the review text, the name of the reviewer, so it feels like this. And the second data set is product metadata, and that data set has just product information. And again, there's the product identifier, the ASIN, and has information like the price and the category. So if you have downloaded the data, you will have access to these two different data sets. Great. So first of all, some Spark definitions. So it's very, very quick, and I hope if you're here, you've already read about Spark or even used it. But so in Spark, we use a thing called RDDs, Resilient Distributed Data Sets. It's the way that Spark distributes the data across a cluster. So here, I made a very quick diagram this morning, but basically, let's imagine that we have a very large data set. It could be a file, or it could be multiple files. And then you can use Spark to send it, or to distribute it across your slave nodes. And within a worker, so this could be in disk or in cache, but within a worker, your data will be split into partitions. So in this scenario, for example, I showed how worker 1 got 2 partitions of data and worker 2 got 1 of them. So I'm going to be mentioning this word partitions a lot, and that's what I mean by partitions. And then also Spark, it's possible to cache the data in memory. Yes. Finally, so yeah, another 1-minute crash course. But so this diagram, if you've been on the Spark documentation, you most probably have seen it already. But basically, a cluster is a master node and some slave nodes. Everything is done through the Spark context. And only the master node has access to that Spark context. And through that Spark context, you can do things. You can transform your data. You can perform every action that you want. And yeah, great. OK, so right. So let's start. We are going to start by creating, so first of all, when you start a Spark shell, you have access to this variable called SC. That stands for the Spark context. By the way, so if you've downloaded that zip file, you should have the Python file. I mean, I don't see anybody typing, so I don't think anybody, yeah, nobody cares. OK, that's fine. So the first thing that we can do is load the data using the Spark context. So I'm going to run it. So I've got some fashion product reviews, electronics products, and sports. And I just ran it, and you saw that it didn't print anything. So why is that? Well, because in Spark, most things are there are two types of operations that you can do, transformations and actions. And everything is lazily evaluated. So in this case, it didn't really do anything. I mean, there was no data movement or anything like this. So yeah, I mean, this is just a link to show you that if you go to the documentation, they will give you all the list of transformations and the actions. So let's see an example. I'm going to look at my RDD of fashion product reviews and just check the length, right, using this map. So map is one of the first transformation that you get to use when you first start with Spark. And then example of an action, I'm going to count the number of lines. So if I print this, sometimes it takes a bit of time, but OK. So the first thing that we see is that it doesn't really print any length or anything. It's just printed the name of the object, so of the RDD. So it didn't do anything. But the other one, on the other hand, gave us the answer that fashion file has 10,000 lines. So this is just a very short demonstration of lazy evaluation of transformations and an action. So only when you apply an action, you actually trigger something and something happens. So let's start with some basic data exploration. We're going to count the number of rows in each file and also check out the first row of the fashion file. So every file has 10,000 rows. And the first row of the fashion file, as we expected, has a product identifier, some reviewer, Abigail. She bought a tutu, and she wrote a review for it. And it's a string. At this stage, this is like it's a text. It's not a Python dictionary. So we're going to have to do something about that later. So I'm going to union everything so that I have all my 3 fashion, electronics, and sports into a single RDD. Great. Yes. And next, OK. So now what I want to do is, because I said earlier this is a string, then I need to actually load it and turn it into a dictionary, a Python dictionary, which is comes in much more handy because now we can just access any field we want. Right. So this is the same data as before, it's just that now it's a dictionary. So something that is also very useful is that sometimes you don't want to perform this whole operation where you load 3 different RDDs and union them, so you just want to pass in a list of files, so that's also possible. You just need to pass in so a comma-separated list of JSON files, and it will do the same operation, but this time there's less code involved. Oh, I had to ask that question before. So something that's very important, or that we found very important using Spark at Skimlinks, is to always keep track of the number of partitions, because we will see later that that's an important thing to know. Like it's an important variable to know later if you're trying to diagnose why your Spark job doesn't work. And so there's this thing called getNum partitions that tells you how many partitions you have. And we have 3 partitions because we loaded 3 files. So when you first load your data the first time, you have as many partitions as you have files that you're loading. And then finally, so again, this is just to show that there are lots of different useful transformations in the Spark library that you can use. One of them is called map partitions with index. I'm not going to go into the details, so you can always go back to the documentation later on. Here, what I'm doing is I'm taking data. So data has all the product reviews. And I'm going to apply a function to the partition. This time, I'm not going to apply a function to every single line, which I did earlier. But I'm going to take a whole partition, so a whole file, and I'm going to apply a function. And my function takes in just the index of the partition and an iterator. And I'm going to count the number of lines in my file. So what we expect is that it will tell me that there are 3 files, and each file has 10,000 rows, because we just counted earlier the number of rows. So that's what we expect. So we have 3 partitions and 10,000 rows. OK, so this is very, very basic. It's going to get more interesting, I promise. So let's imagine, let's try to solve problems. We want to know what is the minimum and maximum number of reviews per product. So there are some products that are more popular than others. So we want to see what is the maximum number of reviews we can get. So for that, we're going to use something called a reducer. So again, it's fundamental of map-reduce paradigm. And in this case, what we're going to do is we're going to count the number of times we see a particular ASIN, so a particular product identifier. We're going to use reduce by key to count the number of times we see each ASIN, and then get the maximum and the minimum. And the way reduce by key works, I mean, this is a very very basic diagram, but let's imagine that we have 5 reviews for asyn number 1. So I'm going to take every row and I'm going to map it to this tuple, which is asyn 1 and 1, because it was reviewed once. And then during the reduce by key, we're going to take all the tuples with the same key, so in this case asyn 1, and we're going to perform this sort of merging at various stages. So every time we take 2 tuples and we just sum the values and do that for across all the data, and we get that asyn 1 was reviewed 5 times. Right. So if we do this, then we get that. Okay. So the maximum number of reviews in this data set is 2,033 times, and the minimum number is 1. Okay. Yeah. So I mean, in this notebook, if you want to look at it later, that we put in a couple of exercises just in case you want to go through it in your own spare time later on. Right. Okay, so I mentioned earlier that we have 2 data sets, right? One is the one we've been working with until now, which is the reviews data set, and another one is the product metadata. So something that's very typical in a data science team is that you need to enrich your data set, so you need to take multiple different data sources and merge them together. So in this case, we are going to perform a join between the product reviews and the product metadata in order to get a bigger data set that has all the information that I want. So first we're gonna start by loading the product metadata, which is as expected. You have the asyn, the product identifier, you have title of the product, things like price, brand, categories, lots of interesting things. Don't worry too much about it, it's just because the categories come in as a list of lists, so I'm just going to flatten that out to be a single list. Okay. So in order to join in Spark Core, Sahar is going to do pretty much the same stuff as me, but we'll show you other ways. But I'm just really showing you here the Spark Core functions. Whenever you want to use things like reduce by key or group by key or join, it typically works with key value pairs. So we're going to join these 2 tables using the asyn, because that's the one thing that's in both tables. So what we start by doing is we take the review data and we transform it into tuples where we have the asyn and the whole review. And similarly for the product metadata, we're going to do the same thing. So we're going to have the keys, the asyn, and then we just put the whole row as a value. So we do that. Right, so as you see, so this is the key, and the second item is the whole product review. So when you do that, so again, something that's always worth keeping in mind is how many partitions do I have on in each side, because maybe later on we might need this information. So now I've joined my data set, so you can use the join function in Spark, and then here I printed an example. So for this asyn, which is the key, we have managed to join both a review that the product received with the product information. Okay. So for example, if now you have a data set, an RDD, which is called joined, and so as I mentioned earlier, sometimes you might want to know things like, how many partitions does this data set have? And in this case, it has 5 partitions. It's not always very obvious why it has 5 partitions, why not as many partitions as the biggest RDD maybe. But I always I recommend going to the source code whenever there's any question like this, because if you go to the source code, you will see that there's a union is performed. So my point here really is that it's very easy to read the source code. So whenever you have any questions like, oh, why is this like this? The best is always to go back to PySpark, how it's implemented, and why, and then you understand why certain things are in certain ways. Right. So now I'm just gonna make a transformation to make this nicer, because right now it's just a key with like 2. It's a tuple with 2 different dictionaries. So instead, I'm gonna merge it and make it into a single dictionary. So now I just have like my first row is my review and my product information all condensed into a single dictionary. Right. So now we're going back here. So, okay. So I'm just going to speak a little bit about the Spark execution model. So why is it important to understand the Spark internals? Well, when things start failing, basically, that's when you need to understand what's going on with your data. And why Spark taking 1 hour to finish this job? Why is it telling me that I'm losing my executors? And that's when the only way to solve those problems is really to really understand how the operations are done behind the scenes. So I just took the slides from this talk. I mean, you should really watch it. It's from Databricks. I just took some of his slides because I thought they were nice. So let's imagine that we have some code. Don't worry too much about what you're trying to do, but the code will involve it's basically definitions of some data manipulations, right? So in this case, we want just to map your data. Then you want to perform a group by key, a filter, and a count. So you know roughly what it has to do and what the output is expected to be. So then Spark takes this code and turns it into a graph of RDDs. So it knows, that you basically have a sort of waterfall of operations. So it knows that it needs to perform the map on the input, the group by key on the output of the map, the filter on the output of the group by key, and so on. But then this is when the things start to get interesting. Once Spark knows this, then it needs to figure out the logical execution plan. So it needs to understand how to perform all these operations in the most optimized way. So something that Spark does in a very smart way is it takes some operations that can be, if you want, like fused together. For example, in this case, let's imagine we would have two maps. If we have like one map operation followed by another one, then you really don't need to go through the data twice. You can just do it in one go, in one data pass. So then what it does is Spark creates this thing called stages. So it will take multiple tasks that can be pipelined, so that can be fused, and call that a single stage. So there's a limit to how much you can fuse, right, into one data pass, and that's why this line is here, and this is where this happens when the data basically has to move around, and in this case, a group by key is a shuffle, and when you do a group by key, you're sending the data that has the same key to the same place. And that data might be all over your cluster, right? It could be in node 1, but also a bit in node 2, node 3. And you need to send all of this into the same place. So that means that your data will travel, and this is a nonlinear type of operation. So in that case, you have to start a new stage. Right, and then once Spark has figured out that graph, then it can schedule and execute every task. So this is an example of a shuffle type of operation where you have your slaves. Each of them has the partitions, so the different files, kind of in disk, and then it has to do something like a group by key, which means that it might have to send every partition to every single slave, like to every other slave node. So this is an incredibly complex operation, and it's expensive, and this is a bottleneck really. When things fail at a shuffle, it's mostly because of this, the complexity. So okay, very quickly here, if your shuffle fails, go back to your number of partitions, because that's typically, the number of partitions is a variable that is something you can change, and that will really change the way that your shuffle is performing. Because sometimes you have like a partition that's way too large, so it's taking ages to finish. It could also be that you have too many partitions, so that's a risk as well. So yeah, read this tuning thing, because that's the best place to start. Okay, this again, other things that can fail. So if you're trying to save a file where it keeps failing, well, don't turn speculation off, which is a default parameter. If you get an error, no space left on the device, you have to make sure that this config Spark local dirs is you have to basically change it. If you keep losing your executors, then it could be a memory problem. So sometimes by increasing the executor memory or reduce the number of cores, it works. So yeah, configuring Spark is not easy. It's getting easier though with 1.6, definitely. But you always have to go back to this, to the documentation. You should always try to read to figure out what's the configuration that right now is the one that you need to change. Okay. So we've done a reduce by key. Now we're going to show you the group by key. So let's imagine that you're trying to get the average product review length for each category. Okay. So we're going to start we're going to work with this nice joint RDD that we had from before. So we're going to cache it. So first of all, what is this? Oh yeah. So the thing is that each product might belong to multiple categories. So I don't know if I can show you. It's a bit confusing here, but yes. For example, this product here belongs to all these categories. So electronics, laptop, and so on. So what you want to do really is to flat this out and just count this as this is one review for electronics, this is one review for computer and accessories, and so on. So there's this flat map operation that you can use. So originally your categories look like this, so it's just lists. And when you apply the flat map, then you just one row, you get one row per category, per element in your list, which is exactly what we want. Once you have this, you can apply something like distinct and count, and that way you can get the number of distinct categories. Okay, but this is not what you were asked to do. What you were asked to do is get the average review length across all categories. So the way you can do this is, so you first do the flat map, where you get one row per category. And then what you need to do is to do group by key. So what you need to do is bring all the reviews for electronics together, and then get the average review length, and do the same thing for computers and accessories and all the other categories. And this is exactly when you need to do something like a group by key. So once you do a group by key, then you get all the reviews for a specific category in the same place, and then you can do something like this just to get the average review length. So if we do this, then what we find is, the top 10 categories by review length are photos, so people really like to write a lot about photos, bags and packs, rifles. Yeah. Right. So I went really fast through this, but I think you can always go back to the Python script and understand exactly how I did this. But I hope you got the gist of it. Now this very quickly. I think I have time. Yes. This is a nice experiment I did to show you how to use the Spark UI, but also to show you one of the big problems of big data, which is data skewness. So what I did here is I created two totally synthetic data sets, RDDs. So one of them has, so you can see here, what is this? Yes. One of them has 16 partitions, and I just completely made it up, where I created a very skewed RDD, where, for example, the first partition has one element, the second partition has two elements, and it keeps growing exponentially until you get one partition that has like 3 million elements, 3.2 million elements. So, and this is very typical of big data, especially when you're doing a shuffle, and I don't know, you have like a very active user So then you're going to get a massive partition with all the user activity for that user, but the large majority of your user base might not be as active. So yeah, this happens all the time. I wanted to show you something. Oh, should. Oh, yes. So this is the Spark UI, and it's your best friend when you're working with Spark. So it tells you things like all the operations that you're running, and then you can actually click on this, and you can understand even more of what's going on. So what I just ran before is basically I joined two data sets where one of them is very, very skewed, and it took about 30 seconds. And when you go to the Spark shell, I clicked on so I went to stages, and I clicked on the left outer join operation, so to understand what happened, why did it take so long. And here what you see is the summary metrics of how long it took to complete each task. And what you see is that the minimum task took 18 milliseconds to complete, and even the median took 56 milliseconds, but then the maximum took 15 seconds. So this is a very clear example of a job that's incredibly skewed. So when you're working with Spark and then you see that your job is 99, it did 99% of all the tasks in 10 seconds, but the last one is taking 1 hour, then that's exactly what's happening. You have a very skewed job. So this is how you diagnose the job. I'm not going to give you the solution, unfortunately, but at least you will know what's going on now. Right. Okay, so I went really quickly. I'm going to show you one last thing because I think there's a bit more time. So something we do a lot at Skimlinks is we use scikit-learn. So we use machine learning to enrich our data. So I'm just going to show you a kind of cute example of how you can use, let's imagine that you have a classifier already that you've trained somewhere else, and that you just want to apply it on your massive data set. So in this case, what I'm doing here is I've got a classifier already, and it's pickled. Okay, so I load it. So you can see my model is just a pipeline with first do a TF-IDF transformation, and then what? And then I think I do there's a logistic regression somewhere. So it's basically a very, very simple classifier. The input to this classifier is text, and the output is the category. And then what I do is I use this thing called broadcast, which is, again, if you're using Spark, is a nice thing to know. When you broadcast some data set, you're basically you're sending it to your slaves, and it will be in memory. Yeah, it will be in memory. So it's really good. You don't need to send it multiple times. You don't need to send the same data. Because if it was just a Python object, you would have to send it in every closure. You would have to send it again. But in this case, you only send it once for every slave. So we do the broadcast, and I'm just going to show you. We have our RDD. We just grab the review text, which is the input to our model. And then we can apply the model by just calling predict. It's like, it's a scikit-learn object, so we use it as usual. And then we apply this. So what we see now is that we get, this is the review text, and this is the output of my machine learning classifier. Great. So I'm kind of done.